Okay, so right now we're going to demonstrate lesson number 2 for you. During lesson number 2, we're going to teach the kids that you can turn an item that's not a magnet into a magnet, and you can also make your own compass. So, Danae, what's a compass used for?
A compass is used to help us find our direction, and it is something that is built so that it points always to north. So whatever direction we're looking, we at least know where north is.
So what is pointing north in a compass?
There is typically a needle that's pointing, and there's some sort of magnetic force that is drawn to the Earth's magnetic force.
Yeah, so what we're going to do, and that needle that you're talking about within a compass is actually a magnet. So what we're going to do is we're going to magnetize a paper clip, and we're going to see if we could turn that into our own compass. So let's look at the phone first. You guys are going to have a real compass, but we have this phone right here. And so if you can see, north is that way. We're going to want to make sure that when we do our own compass that the needle is pointing in the same direction. So here are our items. Danae, can you explain to us what these are?
Sure. So this is a standard plastic cap that is able to float in water. This is a standard plastic bowl that is 2/3 filled with water.
Okay.
And then we have a metal paper clip that's been straightened and carefully cut with wire cutters by an adult wearing goggles to make it straight, and it's about 2.5 to 3 inches long.
Okay, so PLs, you definitely have to do this before the lesson for the students. We don't want them using wire cutters and cutting their own paper clips. It doesn't really matter how long, as long as it's around 2 inches to 3 inches. You don't have to have an exact measurement. So what Danae's going to do now is she's going to turn this paper clip into a magnet. And how are you going to do that?
I'm going to take this magnet and I'm going to use the north polar side and rub it in the same direction each time pretty vigorously for 30 seconds and with some firm, I don't know, force, I guess.
Okay. Okay, set it onto the floating cap. And it should move itself and align itself with the north-south axis. Oh, that did it really quickly that time.
It did.
So why don't you spin it another way and see if it'll go back. And sometimes you have to give it some time to settle. Oh, and it's still going, so they can't rush it when they're doing their observations. We really just have to let it stay still. And does it look like it's settled?
Looks like it.
Okay. And yeah, you can see it. It is exactly aligned to the north-south axis. Isn't that so cool?
That's very cool.
So do another test, kind of spin it around a little bit to see if it'll go back by itself. And I'm going to move it to the middle so I can move. Did we just put it already on the axis?
I think it just turned
By itself.
There you go. Yeah.
So this is definitely wrong. Let's see if it'll go back by itself. Give it some time, it's moving its way back over. there.
Yep.
Does it look like it's
There
stopped?
it is.
And there it is again. It is perfectly parallel to the north-south axis. Yay, we just made our own magnet.